Okay, linear and exponential story problems. The top half of this page is linear and the bottom half is exponential. For linear, the explicit equation is y equals mx plus b. That's the slope-intercept form. And then the recursive equation is y sub 0 equals whatever it equals. And then y sub n equals y sub n minus 1. And then you're either adding or subtracting some value to it. Okay. So on the left side, a man is loading a truck with watermelons. Right now there are 24 melons in the truck, and he places 4 more melons on the truck every minute. Okay. So how many melons are on the truck right now? So 0, 24. Okay. And what happens at the end of 1 minute? There would be 4 more, so that would be 28. And then at 2, it would be 32, and so on. Okay. So how much are we changing every minute? 4. And how much did we start with? 24. So the recursive equation, y sub 0 is right now equals 24. And then remind me what this means. For any year, the calculation is simply last year, and then in this case it would be plus 4. So the recursive equation is y sub 0 equals 24, and y sub n equals y sub n minus 1. And that might seem a little tricky to you, but it simply says, to find year 18, what would we do? Year 17 plus 4. Or, sorry, minute. So find minute 18 would be minute 17 plus 4. Okay? What is this equation really good at doing? Filling out a list. So this equation is really good. It's the fastest way to make a list. What is that equation not good at doing? Going into the future, or going into the past, or even going into like half minutes. Do you think he puts 4 melons on the truck at the same time? No, the truck probably drives and he reaches down and puts them on one at a time, right? But in this equation, can you see how much there was at 1.5 minutes? No, it doesn't exist. Okay, but the recursive equation is going to be, or sorry, the explicit equation is going to be y equals 4x plus 24. Now can we look into the half minutes? Can we look at 2.5 minutes? Well, what is 4 times 2.5? Well, 4 times 2 would be 8, and half a minute would be 2 more, so 10. 10 plus 24 would be 34. So at 2.5 minutes, there are 34 melons on the truck. Also, explicit equations can go back into the past. How many melons were on the truck 3 minutes ago? You'd plug in negative 3. 4 times negative 3 is negative 12, plus 24 is 12. Can I go backwards with this equation? No. Y sub 0 is the beginning of it. Okay? All right. The second question, or the next question is kind of interesting. Would the graph of this equation be a solid line or a dotted line? Why dotted? You can't put part of a watermelon on a truck. Well, I guess you can, but he's not going to, right? Can you put 2.3 watermelons on the truck? No, it's either on the truck totally or it's off the truck. So this would be dotted lines, and probably 1 watermelon every 15 seconds. I don't know, unless he was really strong, he could gather up 4 of them and put them on the truck. Okay? So determine how many melons will be on the truck after 4 minutes. How would I do that? Put 4 in here. 4 times 4 plus 24 gives you 40. Okay. 2.25 minutes. Well, it would be 4 times 2.25 plus 24. And I get 33. Okay, what about 2.75 minutes ago? What do we plug in? Negative. Negative 2.75 times 4 plus 24 gives me 13. Okay. What about the next one? When will the truck have 48 melons? What do we do with that? How do you find 6 minutes? Stick that in for y. So in this equation, it's important to know that x is in melons and y, oh, I did that wrong. X is in minutes and y is in melons. So I'm going to put 48 here. 48 is equal to 4x plus 24. How do I solve that? Subtract 24. And 24 is equal to 4x. Divide by 4, and I get x equals 6. Okay? All right. I'll let you finish that in a minute. Go to the right side. On a long road trip, a car with 22 gallons, a 22-gallon gas tank burns 4 gallons of gas per hour. What would the recursive equation be? Y sub 0 equals 22. And then for any other hour, we take the previous hour and we subtract 4 gallons from it. What would the explicit equation be? Everybody understand that? Okay. Would the graph of this equation be a solid line or a dotted line? This one's solid. How come? What's the difference between watermelons and gasoline? One you can have decimals, and the other one you can't. Now, in the English language, part of it we get right all of the time. Do you have as many? Do you say much or many for gasoline? How much gasoline do you have? Not how many. How come? Because you can't count it. Or you can't count it. It can be a decimal. So you would say how many watermelons and how much gasoline. Okay? If you use the word much, then decimals are included and it would be a solid line. If you use the word many, that means you can count them like watermelons and it would be a dotted line. Now, you guys understand much and many, but you don't understand less and fewer, which it's the exact same rule. So you go to Walmart and it says on the express lane 20 items or less. That's wrong. Because you would say as many items, correct? Not as much items. You could say as much cereal or as much flour, because you can't count cereal and you can't count flour. You can count boxes of cereal. So you would say how much cereal did you eat? Or you could say how many boxes of cereal did you eat? But at the checkout stand it should say 20 items or fewer. So you would say fewer watermelons and less gasoline. Okay, so fewer is countable, and countable would be dotted, right? Less is not countable, and less would be a solid line. So gasoline, do you have fewer gallons of gasoline or less gallons? Or sorry, I said gallons. That's wrong. Do you have less gasoline or fewer gasoline? Less. So you'll start to notice people saying it wrong, and it'll drive you nuts. It drives me nuts. Okay? Fewer means countable. And you can count items. So you could say fewer gallons of gasoline or less gasoline. Do you see the difference? So in this case, solid or dotted? Solid. Because the gasoline is burning at little bits at a time. It's always burning. So, how would you determine how much gas will be left after 4 hours? Plug 4 in for X. How about when will the tank have 10 gallons of gasoline in it? Put 10 in for y. Everybody okay with that? All right. We're going to switch to exponential. The equation for exponential is b times m to the x, or y sub n equals y sub n minus 1 times m. So in the first one, right now an apple tree has 64 ripe apples. Each day, 25% more apples ripen. So the recursive formula, y sub 0 equals how many there are today? 64. And then the pattern is going to be y sub n is equal to y sub n minus 1. And what do we multiply by if we want to increase 25%? This is recursive. How do we keep everything we have and add 25%? 1.25. So basically that's telling us 100% plus 25%. Okay? Would this graph be solid or dotted? Dotted. How come? You can count them, right? An apple is either ripe or it's not. Right? As soon as you say it's ripe, then it counts. But until then, it doesn't count. No decimals. All right. Determine how many apples will be ripe after 2 days. What do we do? Oh, sorry. Other equation. Y equals today, which is 64, times 1.25 to the x. So what do we do for 2 days? Plug in 2. Yep, raise it to the second power. All right, now the next one's kind of tricky. When will the tree have the following number of ripe apples? What do I do with 400? I'm going to stick it in right there. And something happens that makes our life difficult. 400 equals 64 times 1.25 raised to the x. Well, if I try to solve it, and don't, just watch what I do. I'm going to divide this by 64. So 400 divided by 64 is 6.25 is equal to 1.25 to the x. Now, how do you get something out of the exponent? How do you undo an exponent? You take the root, but the square root is different than the third root and the fourth root and the fifth root, and I don't know which number we're using. The number I'm looking for is the number that I need to use. So you can't take the root. And it turns out that it just doesn't work. There's a whole branch of mathematics that we need to understand in order to solve this. So what you do is this. Pull out your calculators. We are going to use our calculators to make a guess. So here is our guess. We go into y equals, and we type the formula 64 times 1.25 raised to the x. Everybody got that? 64 times 1.25 raised to the x. Got that? Now, push, not graph, but second graph. Second graph. And you should see a table. What am I looking for? I'm looking for y equals 400. So I'm going to go down. So what do you think the answer is going to be? Well, 9 is a little bit too big, and 8 is too small, So 8 is 381 and 9 is 476. Are we going to be closer to 8 or closer to 9? Closer to 9. So let's try it. Now, the easiest way to try it is to push trace. So I use second table to find about what the answer is, then push trace, and it will graph. Oh, you have to make sure. Is your window wide enough to capture 8.2? Well, is 8.2 on the x-axis in my window? Yes, the graph isn't, but that doesn't matter. As long as the x value is in the window. Could I plug in 100? No, 100's not in the window. So I'm going to type in 8.1. Oh, oops, sorry, trace 8.1. Enter. Is that big enough? Push zoom 6. Did that fix it? Okay. Well, 8.2 was not big enough. So I'm going to just, you don't have to push trace again. You can just type 8.1 wasn't big enough. 8.2 is really close. 8.21. Oh, almost. 8.22. And I got it. Now, if I wanted to do 1,220 apples, so now push second table, and I'm going to go down until I get to 1220. So 1220 is somewhere between 13 and 14. Is it going to be closer to 13 or closer to 14? 13. So if I push trace and I try to type in 13.3, it won't let me do it. How come? It's not on the window. So look at your x-axis. Your x-axis goes from -10 to 10. You have to make your x-axis bigger. So we go into window. And how far out do I need to go? I got to go past 13. So I'm going to go out to 14, enter, and then I'm going to push trace. And now I'm going to try 13.3. Maybe. We'll try this again. Okay, trace. Wait for it to graph. Holy cow. I'm gonna oh, we want 1220. So 13.3, I got 1244. Do I need to go up or down? So 13.2 is a little bit too small. 13.21. There we go. 13.21 is the answer. All right. Go to the right side. A pond used for irrigation has 36 acre-feet of water. 15% of the water is used each week. So the recursive model will be y equals, or y sub 0 equals 36, and y sub n equals y sub n minus 1. How do I lose 15%? No, so when I added 25%, I took 100% and I added 25%. So now I take 100% and I subtract 15%, which gives me 85%. So when we talk about losing value exponentially, you always state how much you keep. So losing 15% is the same as keeping 85%. So it would be y sub n minus 1 times 0.85. And that's a 15% loss. The explicit formula is y equals the starting value of 36 times 1.5 to the x. Oh, I forgot to say this. Apples, dotted or solid? You can count the apples, right? There's no decimal apples. It's either right or it's ripe or it's not. Water in a pond. That's a solid line because a little tiny bit is always leaving. Oh, you had it right. You just wrong question. Okay, good. All right. How would you find 4 weeks? You'd plug 4 in for x. How would you find 8.338 acre feet? We would need to put the equation in our calculators. And 36 times 0.85 raised to the x. And then I do second table. And this will help me find the number I'm looking for. And it looks like the answer is exactly 9. Right? 9 matches up with it exactly. 8.338. So the answer is 9 weeks. Okay, what about 1.93? If I scroll down, let's see if I hit exactly 1.93. 3.1, 2.6, 2.2. So at 18, I ended up with 1.93, and at 19, I ended up with 1.64. So the answer is somewhere in between there. What should I guess? 18, I got 1.93. Oh, is that it? Oh, never mind. Okay, that's it. Sorry, I thought it was 1.83. We got it. How long will it take for the pond to be empty? It's never going to be empty, right? Because the amount leaving it is slowing down. But eventually, the pond's going to dry up. Eventually, there's so little water in there that we don't care, right? You get to a point where the dirt's just wet. There's no standing water. There's just water in the dirt. And even that can dry up. Okay. I think that's everything you need to know. You need to finish the first page and the second page. And then, oh, you can throw away the honors creation. We're not going to do that. Okay, good luck. So if you're in an honors class, you need to do the honors page. But if you're not in an honors class, don't worry about it.